So hello everyone and welcome. It's amazing to see you super crowded here because we also have Ecosystem Summit happening at the same time in parallel and it's quite crowded. Thank you for being here. So I'm Esra. I'm working in Antigua Mobile GmbH, which is based in here. And who am I? If we check, you probably see and heard a lot about Flutteristas during the conference. I'm a public speaker in Flutter communities, also organizing. Currently, we also have edition Flutter Berlin meetup. So you can see me around quite a lot, let's say. But before we dive into topic, we also highlight this in yesterday's Flutteristas panel. And I would like to ask, can you guess a number which is software developer gender distribution worldwide as of 2022 as a ratio maybe 60% male, 40% female, or 70% male, 30% female? Does anybody wants to guess a number? Can you say it louder? 85% male. I mean, I would say it's pretty close because once we... Yeah. Now you have the cue. So it's the Statista results that we have 91.88% male represented individuals as software developers. So that's why actually communities like Flutteristas matters in this front. There is a huge gender gap happening. And thank you for being so sensitive about it yesterday and joining the Flutteristas panel as well. And if you would like to support us, we also talk about how to be an ally in this front. We have the Flutteristas conference coming. We had it last year. This year, I assume we would also do it. And feel free to support us in any form. We will be reaching out about it. So now we will take a tour related to gestures, and we're going to go beyond the gestures. And what we're going to talk about is, of course, touch screens, types, how they work, gestures, gesture detection, gesture arena, awareness movement. And I had a chance to do some research and found some interesting stuff that probably you might be inspired as well. So I also have that part. It will not be super, let's say, code-focused talk in this point because gesture detection, all library is just open and publicly available, that you can directly see how the function works. Whatever code I show, you will still use on tap, you will still use on double tap, and so on. But we will go beyond the code and we will just see how it is working in theory and literally physically how it is working. Because now everything is just one ChatGPT away. So let's grasp the concept first. So how many of you remember their first phone, which is not a touch screen? You can raise your hand. Quite a lot, entire. But we always have it in mind, maybe you have it in mind while you're a child, maybe you learn it later, maybe not. But how can a glass know that you are touching? Literally, if you think your phone screen is literally a sand that you are molding it, then let's say you're having a glass, then you're having a little bit chemical manicure, let's say, then you're having a Gorilla Glass. So literally, we are having it in iPhone screens. So one of the, let's say, really important points was what made the iPhone launch in 2007 revolutionary can be about this topic. Does anybody has an idea? Yeah, please. Exactly, the capacitive one. Apple is the first company to launch a touchscreen smartphone in 2007 successfully. I mean, there have been a lot of attempts. The keyword here is successfully being able to ship it. And it is compact, user-friendly, and it has multi-touch functionality. It is something that we didn't have before. So that's why 2007 Apple launch is revolutionary, related to even gestures. Before that, you just can't do multiple gestures. You cannot use your two fingers. Simple. Then, Okay, we heard about it a little bit, we know about history a little bit, but how does our swipes and taps are translated into code? The screens that you mentioned are actually called like resistive and capacitive screens. We have two different screen types. So the resistive ones that we see is like kiosks, ATMs, like these kind of devices that you see in everywhere, like in McDonald's, Burger King, whatsoever. And the capacitive ones, literally our devices that we are using right now. And if I ask you like, what is the main difference between them? Probably your first response would be like sensitivity, because you need to press pretty hard to do things in ATM, like considering your smartphone. And also what you can think about is like when you are trying to get the money from ATM, when there is a direct sunlight, you are having a hard time to seeing it. That's actually one of the issues of resistive screens. That's why it's way better in capacitive screens. They are different in technical level. So resistive ones, it's the one in ATM, kiosk, and so on. This one has 2 layers, and it's lathered a conductive material. So what does it mean? When you actually literally press it, when they touch each other, it gets the electricity part. Like it sends electricity to processor with XY dimensions, like a plus sign. And then a processor can match up what's on the screen and register if it needs to do anything. Because, we say, okay, like 50X, 50Y, is there a button or not? If there's a button, yeah, we gotta do something. If there's nothing, then we will not do anything. But when we go for capacitive screens, then we go for 4 layers. So the top layer is typically made of like the glass that we mentioned, like durable Gorilla Glass thingy. And beneath these glass, then we still have the ITO. The ITO means like indium tin oxide. So it's an excellent electrical conductivity material that you have. And we have an insulator again between that. So just to mention, the grids we see up there, they are actually not blue and red. It is just illustrated as blue and red to be able to see it clearly. Because when you touch the screen, now your finger is gonna interact with electrical field, but you're gonna do the change in positive charge on the top layer. Then the device is gonna detect the change, pinpoint the exact location thanks to the diamond shape, and then how it actually understands what are you doing. That's why, since it's related to electrical field, that's why when you are trying to use it with your gloves, it's not working. Because you cannot simply mess up with electrical field with your gloves. So they are literally just behaving like insulators. So when we just compare between two, so we say resistive ones, like not sensitive much, but it's durable. That's why I can use it in kiosk. That's why I can use it in McDonald's, because it's just like, it's durable, it lasts longer, it's just enough. It is hard to see it outside, like in ATM and so on, but it's better to like think about you are using iPad like ATM thingy. When it's broken, then you just can't do it. So also, one of the other things of resistive screen, connecting it with the Apple Lounge, that's why you cannot zoom in this kiosk or ATM stuff, because it just doesn't understand multiple touch. That's how actually Apple introduced the gestures properly to our world. And again, because of the electrical field, that's why we are having issues while we are using our iPhones during a raining or when your hands are wet, because it is also messing the electrical field like you. So the processor trying to get to do the math, but it cannot say like, oh, the change is here, because it's just messed up around with the water. And of course, we know these gestures. We have like tap, double tap, long press. These are gestures like you can easily recall when we are talking about it. And let's go to the Flutter side of it. Of course, the first widget we have it in our mind is gesture detector. And it's just detecting gestures, simply as it says. And here is a simple output of offsets, what it can detect. So we see X values, Y values, but it should be a little bit more. Like Flutter turns into this code, to actually this one, because we have now tap gesture recognizer, then it is actually have its own recognizer, and then on tap it just prints out what we are trying to do it. But it doesn't seem like a raw data we are looking for yet. Like we talk about diamonds, we talk about like, X, Y values and so on. So to get the exact raw data, we will get help of listener. So we have on pointer down, pointer up, pointer move. And if we run it in dartpad, now we started to get a little bit more detailed. Like now in this printout, you can actually see coordinates, timestamp, kind of it, device, because pointer, device, kind, mouse, it could be also pencil. It could be also like a trackpad, it could be stylus, or it can be touch. So there is another layer of complexity while we are getting the gestures detection, because now you see the output, it's actually output of like stream of outputs. Now we're gonna have a lot of logs, but our main question is, I have the first data arrived, but how will my function gonna understand whether it is a tap, a double tap, or a long press? I only have one output. I can't see the feature, the function cannot see it do, so how I'm gonna resolve it, like what we're gonna do next. So there is something called gesture disambiguation to directly describe this topic, to make sense all of this. And we have gesture arena to understand what it is doing, how it's worked. This is actually a great talk and explanation by Craig in Flutter team, but I will just keep the key parts of gesture arena for you to like understand what's going on. Okay, I'm waiting for the pictures. All right. So we have three main gesture recognizers in this example, which is like tap gesture recognizer, double tap gesture recognizer, and long press gesture recognizer, and gesture arena members. So it is really like an arena. They're gonna fight. They're gonna fight to understand which one is winning. And we have actually two rules in this front. At any time, a recognizer can declare defeat. It will be just like, you know what, it's not me, I'm out from the arena, like I'm out. Or at any time, a recognizer can declare victory and say, oh, it's definitely double tap, you are out. So we only have two rules to understand. And if the recognizers are just leaving arena, last one stays, also win. So it's a little bit sounds complicated, then let's go for an example. So let's say all are fighting, the first one has started, we have like tried to just focus on, I would say, words and values, like tap recognizer, double tap, long press. So first touch, then our user actually had the first touch to the screen. So the fight has started. And around 50 milliseconds, the pointer up event received. What does it mean is just like user literally lift a finger. So this will immediately eliminate the long press recognizer, because normally long press recognizer would just wait till 500 milliseconds at the end. Then it would say like, oh, it's a long press, but it's too early. So it's quite early, it's loose, it accepts defeats and leaves the gesture arena. Long press is gone, we only have tap recognizer and double tap recognizer. Now we need to still keep waiting. Let's say nothing has happened till 300 milliseconds. Now they are in the same position until 300 milliseconds, and tap recognizer and double tap is just waiting. Now what's gonna happen is double tap will be like, it's already over like 300 milliseconds. It is definitely not a double tap. The time between is just too long. It's just gonna say admitting defeat, I'm out. So we only have tap recognizer left at the end. And this is how the recognizer gets the win. If you actually, so if you actually try to put print logs to like, okay, on tap print, on double tap print, long press print, you will also see that always the last one printed will be the like single tap, because it's waiting forever. So just gotta understand everything, whether it's me, it's not, whether it was a long gesture or whether it was a double tap, it's just gonna wait. So we covered about main part of screens, how does it work with the electrical fields, gesture types, listeners in Flutter, how the gesture arena works. But there is actually another part while I'm doing it, giving me inspiration related to research and what's going on related to gestures. So let's see, what do you think maybe as gestures we have in our real life, or let's say displays we have? What do you think how we could improve this? Just giving a little slight second for you to think like what could be more than what I'm telling right now. Is actually military grade displays. These are the stuff that we are not used to have it in mobile world, or we are not talking about them in Flutter world yet. But military grade displays, like they are specialized and they have totally crucial components there. And it is also, let's say, part of really looking like capacitive screens, but it is, we are calling them, where is the name? I think it's the next one. We have near field imagining ones. And now we are talking about totally different gestures. We were talking about double taps, swipes, and so on. But now when it goes to military, now I need to be able to use my gloves. Maybe I need to be able to use my both hands, though the gesture, it can be wet, it can be, I don't know, muddy. I still need to be able to interact with this device. So there is actually way much more than this. And while I'm still doing the checks, I see like inspiring research outputs. Like there is an app I see it in Google Play Store called Justify. And Justify is literally an app that you can assign your gestures, and then you will just have the shortcuts about what you're doing. So with the M letter, then they are just calling mom and so on. This is a research. And while they're actually trying to introduce the gestures, you need to do literally articles, research about like how people are drawing it, how people are doing it. Because as you can see in the lab study second row, when you check the field study, it is not matching at all. Like the first one is not that bad, but the lab study is not enough itself. So we need to do field studies to see like, does it really like W to launch WhatsApp for everyone, or should we use icons? What should we use? Or there is another research. It is also, again, one experimenter, one participant. There's a screen, computer, and camera. Now you're watching what is the person is doing. And in this research and articles, you can see like it is assigned to do like, let's see, send an item that is visible on your phone, stream a video file, abort whatsoever mission, pause the current thing. So like literally this people are doing these interactions, and we are just checking how they are doing it. How good they are doing it. Are we meaning the same thing while we are doing the gestures? And there are definitely so many parameters while going under this one, like distance, touch, location, rotation, delay, duration. What does this all mean? Like, am I moving my phone while doing this one? For example, we have wake up function in iPhone, or sometimes I just need to change the device. Maybe I'm just rotating it. These are all parameters that we need to be careful of, actually. And this is an article published in September 2010, which is just like 3 years later iPhone release. So for example, in this study, like we can see different, like this is the one that I mentioned, like video recordings, understanding gestures, what's happening. Like second row, yeah, I think second row, yes, it's the second row. It has the pointing gestures that user trying to like put the phone, get back, and so on. And it really looks like iPhone's wake up functionality, right? And this is just like 3 years after iPhone release. And when we do research, we also need to be extensive. If you want to be inclusive, there is way much more individuals using it. This is another research done with individuals with Down syndrome, centered on design for all. So you can see different types of Down syndrome. You can see like their gender, you can see their socioeconomic status and everything. Like you gotta check everything. to be sure how your user is using the application. And you need to prepare some simple tasks. You need to have some tests. You need to gamify them to be able to keep their attention, to understand whether they can complete the tasks that you are looking for. And these are some individuals like taking this test and experimenting. And of course, at the end, we have failure cases and success cases, whether the individual can perform this action as we want it. And it can really vary. So these things are really important to be careful actually while introducing new gestures. And you can also see success rate and failure rates by type of Down syndrome. Or it's also varies. Like beyond other individuals, if we want to have the inclusive design, we need to be careful while we are introducing it, or while we are talking about accessibility. We need to at least know whether the individual we are targeting can perform this action. And now it's time for thinking for our habits, like how much it is in our life. Like we are using a lot of gestures automatically. Like when I say I'm scrolling on Instagram, you always have it in your mind that I'm just like scrolling down. When I'm saying, oh, I like the picture, you can easily imagine I'm double tapping the picture in Instagram and having the heart emoji. And I don't know, I sent a fire to a person in Instagram, then you will see like, oh, okay, swipe up, then fire emoji, single tap. Then it's happening. See, so you actually have it in your mind. And there are now 2-year-old kids are just like, even smaller than 2 years old, scrolling in TikTok, scrolling in YouTube, taking selfies and so on. Like they are already able to use these devices. So our habits are evolving, and the regular phones, like we had the regular phone touch, now we had the button ones, now we have smart ones, capacitive screen ones. Like it's just evolving every day. And these gestures are not simply actions, that now they are primary means of human interaction in 2024. Because now you're taking off your phone, tapping something, it becomes letters, I'm seeing it, and now this is how we are communicating. This is how people are having fight in their relationship. This is how we are just having fun with it. So it is actually just way of communication right now. And I just want you to like be more aware when you're using gesture detector or any gestures in your app. Like there is way much more beyond going on that we are just using simple on tap, double tap, but there is a lot going on behind. And now what's next in the future is we see like, okay, Vision Pro and stuff is happening. The kids were mocking our TikTok behavior, mocking our YouTube behavior. There was actually a video that I couldn't find, but it's a small kid watching his dad, and his dad was wearing Apple Vision Pro and doing the selection pinch in the Apple Vision Pro, and the kid, like 2 years old, trying to mock the pin behavior, like trying to mock that behavior, because this is how will it be. Like we are getting some, I don't know, again, Reels, TikToks, like, generation difference, make a call. Then you see like, okay, Gen Z is just doing it like that. The other one is doing like that, or some other one is doing it. So now it's becoming a pinch. It's becoming the TikTok stuff. So I just want to raise an awareness while we are using these technologies. And thank you for listening to me. This is actually like end of my talk. And here is a QR code that you can actually leave feedback. And I'm going to put all resources into that you can actually see the articles. You can actually see the designs, experiments, and what's going on. And please feel free to send me what could be so weird or fun to implement as gestures, so that we can maybe make an app by that. And we will give it a try, and we will see it in upcoming conferences. So thank you.